example 1, okay, we're going to graph y equals -2 log base 2 of the quantity x plus 2 minus 3. And since this is a base 2, we can't use the graphing calculator to graph it. So we have to understand what each of these transformations does to the function so that we can transform the parent graph and get an accurate sketch. So if we start by identifying the a, that's a -2. The b is the base of the log, that's a +2. The c is the coefficient on the x, and our x doesn't have a coefficient in front of it, so we remember that that's a 1. Then h is the opposite sign of what we see here. X minus -2 is x plus 2, so our h is a -2. We're going to the left. And then our k is the constant at the end, including the sign, so k is -3. Okay, the asymptote, because we have a vertical asymptote, for the parent graph, it's going through the line x equals 0, right? Now, if we do a horizontal translation to the left or the right, that's going to change the position of our vertical asymptote. So the vertical asymptote is always going to be equal to the h. So my vertical asymptote is x equals -2. So we can come over to the graph and put a dashed line through x equals -2 to show that vertical asymptote. Okay, then our anchor points are going to come from the b. Remember, the x-intercept of the parent graph is always 1, 0, and then the point b, 1, which would be 2, 1, and then reciprocal of b, -1, and the reciprocal of 2 is 1/2. Then to take care of the vertical stretch of 2 and the reflection in the x-axis, we're going to multiply all of those y values by the a, which is -2. So each of the x coordinates stays the same, 1, 2, and 1/2. And then we take 0 times -2 is 0, 1 times -2 is -2, and -1 times -2 is +2. Then we're going to do the horizontal stretch or shrink or a reflection in the y-axis by dividing the x by the c, which is 1. Now when we divide each of these x values by 1, we get the same point back again because there is no horizontal stretch or shrink or reflection in the y-axis. So I'm just going to cross that one out and move on to the horizontal translation, which is going to add h to the x, and our h is -2. So our new x is going to be 1 plus -2, which is -1, and the y stays the same. Then 2 plus -2 is 0, and the y stays the same. Then 1/2 plus -2 is -1.5, and then the y stays the same. Then our vertical translation is accomplished by adding k to the y value, and our k is -3, so this is going to go down 3 units. Our x's are all going to stay the same, so -1, 0, and -1.5, and then to find the new y coordinate, we take 0 plus -3 and get -3. -2 plus -3 is -5, and then 2 plus -3 is -1. So we're going to plot these transformed points now at -1, -3, 0, -5, and then -1.5, -1. Okay, I gave you an extra guide point already here on the graph since we haven't learned yet how to evaluate a log function by substituting a number for x. We're going to do that in a future lesson. So for now, I know that this point 2, -7 is also on the graph. So my function is going to come along this vertical asymptote, then bend through these transformed points, and that would be the graph of my log function. Okay, the domain is based on this vertical asymptote at -2. So my function is starting at -2 non-inclusive and heading to positive infinity. For the x values, the range is the y values, and the range of all logarithmic functions is fully unbounded, so -infinity to positive infinity.